January 2026, I am right here thinking about this problem that's been in my mind. Half step. Okay, basically, today's video is on cloaking. But basically, I was gonna make this about this seaweed cancer stuff. But basically, seaweed was like because they have a cancer system. Basically, women don't get breast cancer or any kind of cancer when they have seaweed, but we don't know why seaweed does it, because seaweed is material but it comes under the sea. It's a weed, and it's like a kind of plantage that goes on a weed, but it's like a moss. It's like a moss that grows in grass, because there's a lot of damn grass, but seaweed is the same thing as moss. It was under the sea. So I'm looking for solutions why that is, because it affects cancer. Can use moss too, but seaweed clothing, it works. It works. Because you have seaweed, if you make seaweed out of clothing, you can prevent cancer. That's the policy. You have women that wear seaweed clothing. I don't care whether it's tight or not. They have to be doing seaweed and moss clothing, because because the kind of properties of them, the system, they're not just like nothing that grow in the water. But that's the problem, because they come from underwater, and that's why that fucking works so well. Because it prevents in the long run, prevention before cure. Obviously, these are the materials that matter. It's people. I mean, because I want to wear tights that don't itch me. Because tights that itch you, not for you. You just know that if you're a woman. And they're men tights, so men can wear all women's clothing. It's a plus, this much. Okay, let's continue. And, oh no. So basically what I'm doing today. So what was I doing today? I was clicking here. Today, we're looking at here. So this is github.com /OGIKE -core. O for Oscar, G for Golf, I for India, K for Kilo, E for Echo, dash, C for Cake, O for Orange, R for Romeo, E for Echo. This is what's my fucking name? This is my fucking cloaking system. But I don't have the money to do it, so I'm gonna do it. But I have to have the material to do it. But this is a cloaking system. This is a actual cloaking system. So this is this is where the proof lives. Oh, it can live with it gives of HPR proof, peer review proof. So the proof is all here, but it's all scattered in the patents repository on github.com/OB patents. But you can look for the full things there, but you have to find them. And don't guys get indexed too much. So this is the first one. I'm gonna explain it in layman's terms. I'm gonna have some fucking breakfast because lunch is 12 a.m. now. So definition: classical force-field field. A force field is a vector field F that's mapped. This is a mapping of R. This is a row space to the power of n. For every real n, implies that every real n that you assign, that assigns to every point R. Sub point R, because so every point R in the row space R, which is the big space R, where R ends the dimension, because R to the power of like an n vector, 2D, 3D, for example. So for F is defined as a force field. The colon means a mapping from real space to any other real space of n. So it maps to, it can be one dimension of real space. Implies it's a mapping between any dimension of real space that you're operating on in the physical or the metaphysical, just depends on the dimension you're in. R is a subset of Rn, a vector force R. So this is R, the maps to the force field, responsibility, the test particle at that point, the particle that interacts with that force field. So this is basically the principles of this. This is just definition, and this is why it matters. It's textbook accurate. It matters, and that's how the definition of the force field is. So if this definition is sorted, we don't get force field, and this is accurate. This we get enough of. This foundation. This is like the this is the proportion. This is the theory I'm proving to be true using a lemma. What's my fucking lemma? Where's my lemma? My lemma is okay. My axiom. Oh yeah, this is my axiom. But it's my lemma. I'm going to use the lemma. This for say fossil. Quantum field force, CF of prime. In the opening, we studied the association of division in quantum charged particles interaction. replacing graviton and saying there's no graviton, where there's no graviton in standard quantum physics, there's no graviton, don't see the graviton, because everything happens in wants to be a separate. The fermions wants to be separate, and the fermions are causing problems for us because they like to change stuff when we don't need change. You say, basically elementary particles in quantum physics. So these are elementary fucking particles. These are muon. So basically, these are the muon neutrinos. But you know, I'm just gonna try to get this fucking image up again. But this is why it's gonna be small. It's easy to open up, because it's so annoying. But the electroferminals have a half integer spin, and you know they are leptons, but they anchor the bosons. Basically, the bosons are separate, but it's just like a table of the leptons on the outer leptons. You know, I think that we gravity, everything that gravity is, and everything that wave is operation. But there just be no exchange in them, because you know they don't want to be together. They don't be together because they have different properties. So kind of the three generations of the third generation is things already stable. So electrons, electron neutrinos, muons, tor. You know, these ones are things that dictate what they are. You know, get up and charm, the strange and the strange and the charm. So the charm of things, profound in composition subarticles, such as, but you know, I'm not gonna, because they work on spin. They work on spin. They work on spin because they are measure of forces. They're forces you have to go. Basically you have to have energy for them, and that's why the lambda calculus work. You know the energy is there. You know you have to use lambda calculus to do the energy measurement. You have to use the right energy for the right measurement, because everything is an interaction at the quantum level. It doesn't matter because you read something, someone's writing to your buffer. You know, because things, you change the state of your computer. You know, and your person's computer, your friend's computer, you use the same. So this is one Higgs boson, but this is the God particle, because it appeared in space after. So, look, I'm not gonna go about this. It's not important. It's not making sense to me. But this is what I'm saying. So these are the the particles here, the leptons. Yeah, it's what I was looking for. The photons. Now, the photons, what I'm talking about, the photon and gluons, because it's part of the quarks framework. So this one's going to focus on the photons today. That's what we're going to focus on. Sorry guys for me. But this is the photon carriers. But this is the force carriers. So the photons and the gluons are one. This is separate on the table, but they're the force carriers. So things that have force. I'm just focused on the quark level, not the lepton. But they're the same thing. You can use the Z boson and the W boson with boson. But the Z boson is like you get the gluons, which are the force carriers. But how am I saying? Basically, they have force. They need to do force interaction at this level. Cause and effect. Give a full is a gluon or photon. You know, basically, it's not even a quark, because the quark is something. It's an elementary particle for other uses. What's the quark here? So I'm saying top, because you get the quarks. Yeah. But quarks have spin, up, charm, top. They have spin, they have direction. But the quark has a direction. But the photon depends on how much force it needs, the photon, and that's what we're for. So it makes sense. So basically, if you look at this model, you get a description of the thing instinctively, and you don't fuck up your mind, because I can say to you a lot of things like polarization. You have to reference the table, and the table gives you. If I have the same table as you, I'll make a mistake. It's basically just go look at the table and tell me I'm wrong, because it's quantum physics we're doing here, guys. So back to the video. Back to the fucking. So you get this. A charge of a polarity, so a charge replacing graviton. The graviton is changed because there's no gravity particle, graviton in the model of standard elementary function. That's what it matters, because there's no actual gravity particle on its own one system. What is it? I'm fucking.
Andy, your lunch is ready.
Yeah, okay, go on. I'm coming to get it. So the lattice-based coherence operator is the go-to because the coherence measures the change of a system, of a stable system, and this is what used to make my system stable. People is coherent, it behaves accordingly to the correlation of the goal. It doesn't matter how much code I write. Basically, the functor frameworks repository on GitHub is like what this the thing is about. But the Lagrange transform is the holy grail of everything. The Lagrangian transform is the non-gravitational. This is the holy grail of the system because it's basically Eulerian and Hamiltonian coherence, but that's like defined in the framework of organization as a policy. This is the policy framework. Because the change of psi of R, the kind of change of the phi. This is not psi because this is not PSR. This is high, P watch high. This is psi. Psi, I think it's I say wrong, but it's psi, PHR. That's what I'm saying. It's not because it's quantum measurement. They're taken over away. It could be away from. I'm saying the psi hat is of a radius. I don't know how to pronounce this. Fucking high. But I don't know how to pronounce this. I think I pronounced it wrong. Yeah. So, I don't know. But I'm saying this. So definition: quantum correlation project, lattice-based coherence, Eulerian Hamiltonian recoherence protocol. The quantum formula is a false negative change of psi. Oh, this fucking symbol. But this plus the constant coherence operator psi, which is the measurement of the radius of the maximum wave function. This is wave function measurement of wave function. This is a quantum potential operator. This is like a potential energy with kinetic energy of mass, so it measures potential energy too, like work done. In a quantum sense. So this is psi hat for the dimension IJK, but this IJK is indexing one dimension or so. So the masquerading is like this spiritual masquerade follows because you want to make things visible. So before I continue, I'm gonna say to you, so you get spider web. What this means, you get a spider web, which is a light. We call that for spider web photodynamic because it has a mass. The spider can hold it and can swing on it all it likes, and it doesn't break for that spider. This man has to be the spider fucking get. The spider follows the fucking web. Let's sort of color because you don't see the web, you see the spider dangle. But there's no fear in the spider because the spider knows it can interact with the web. It doesn't see the web in the dark. So the spider knows what because the light for the spider is for the eyes. It doesn't need to. So the spider just needs to conjunction over, and it doesn't matter how much light is shine on it. The web holds the transparency on all angles. You can't see the web at one point. So there's one blind spot for you. No matter the light you give shine, really, the blind spot is what makes it visible. There's one, the blind spot is the radio wave. It doesn't matter the kind of color of the spectrum you're using. The mass of the physics holds the spider, and you're able to see the spider in the dark. No matter the color of the beetle, it's one blind spot that whatever angle you take, and that is then visible. That's how the force field works, and you use to amplify that vector from your angle, and you'll be visible, and you project that in the other direction, in all directions, and you'll be visible. If you're in that spider space, you'll be visible because if that space is span, like the thread spin, the masquerade holds, and that's what I'm saying. The force field, the area holds as invisible because it reflects everything that is nothing that you are seeing, but you can move through it. You're invisible basically. So this that works because of it's not a hard proof to do. It's a hard thing to do because you are taking your blind spot and you're trying to see what you cannot see. So you have to take a picture of all your surrounding ahead of you. That's what's hard. But yeah, the blind spot is the goal of it. So that's why there's no gravity involved. Because if you can measure gravity, that means you can measure everything that's not around you. Basically, you're already flying. I'm saying you can do that opposite, but it's not possible. So this is the Mount M theta psi. I didn't know the symbol, guys. This is like the spinning symbol, but this is a spin of a dimension IJK XYZ of time, mapping to the space S. But this masculine field times r makes C cubed is a dimension of 3. But this is this is the masquerade field. So the masquerade field is just the space of the masquerade, which is like medium.com/OBNSS. But the topological invariant of that is the span encoding because the width effect it's like the dimension you're operating on locally is the Lagrange 1/4 pi. Now 4 pi is not half pi, so you get pi which is one polar measurement. Half pi is the one half polar measurement, which is 180 degrees or minus 180 degrees if you're going counterclockwise. But half pi is pi divided by 2. But you got the area of pi, which is pi area, pi radian. But pi radian is 1 full rotation. But if you get six double pi or 2 pi, you will get, because this is 4 pi here, you will get 2 polar rotation, which is over Laplace rotation. Now, this Laplace rotation is an integral dimension to system, but this 4 pi is just chemical state for this execution. It doesn't matter how much you spin it. You have to spin it 4 times, and take the measurement over an integral m dot the Laplace 0 times m dot the Laplace basically it's a backward 6 and saying and that's it's a big thing to do, but this is because it's energy consumption, and this is topological invariant. This is like the surface area that you want to maintain around you, and this is what we're saying. So this is topology, because it's what you already have to protect, to say, so for everyone to see. And we can take it to tomographic, which is the area variant of it, which is the outside. So this will be outside where you can see too, because tomography means your area, because you can do you can use this for tomographic as well, Laplace integration. So this is tomographic, well, it's like topology one, but I believe the tomographic was much easier to take, and I don't want to do that now because I'm saying, so the Lagrange transform approach to no gravity dynamics, because gravity is not put into the model, because gravity if you start to gravity at the quantum level you're gonna rip the fish to shreds, and that's what we did gravity. It's a simulation of a problem, and it's a good one, honestly. So 1 plus 4 minus 1 plus 4 fu plus 1 half do but this is lambda, this is like a power set minus, and this is same. This equation is including no gravity involved, no gravity particle, and this way you need at all times. You just never don't gravity take control, don't take mass, because the complex scalar is the Phillips mode. Oh, this is the complex scalar, so I put in civil collapse energy. And this is the civil collapse density. This civil collapse is like something's they're gonna happen in real time, but the electromagnetic gas is stabilized, so it's measuring this to see what is the energy density has depth more than it is, so you can get the system. This is a tensor, so this is a matrix, but it's a biometric ratio called a tensor. So the Mensa is like if you have two sets of matrices that overlap in one dimension, you get a tensor. Because one dimension using two matrices, no, you don't need one dimensional problem, and the dimension is just what kind of problem you're solving, because you need a tensor for complex fields, but you don't need a tensor if you're working with dimension. Just just use them for systems of linear equations that are partial differential in the worst case. But the partial differential is this real question between the calculus you're doing and I'm doing, and that's where the lattice equation comes in. And you see, so the Coriolis derivation of the lattice field is in joint mode. So the joint mode is joint amplifier. Should we amplify my signal to make it be coherent? Should I disjoin? But this is a precise core. Should I join more signal, because it can be day and night, and day and night if you want this to last, the system must do it itself. It doesn't matter whether it's an optical illusion or not. You don't want it to break the kind of the because because the intensity of the light changes from the sun, and you get some mirage formula that reveals your position. Because it does happen. This is a macro version, and this one said the reflective index modulates So basically, this is what I call the reverse modulation. So the civil Lorentz energy of the density and the force interact via the coherence variation duration, or the integration of the area over space time. But so you get the reflection of the index modulation. Modulation just means you're tuning out. It's like me, a voice modulator or system modulation amplifies based on the tomographic system in the world view of you, and that's what it is. It's optical invisibility based on the time, day, weather, things that you can't really account for. Because if I have a voice, when I'm tuning my voice, I'm becoming someone else. I'm reacting. So Hamiltonian particle joint. So you get joint more disjoint recording rules, and we get rejoint for broken lattice. Repair. The system phenomenologically. Zero glue. So basically, zero glue principle. Very important. The system actively achieves phenomenological coherence. No surprise it was around him through direct consciousness mapping without. It's like conscious because he knows. I call it conscious is actively and sparse based on the tomographic state of the environment. Yeah, cha cha cha. Let every collapsed curvature become our shell. Every evil chant because chant or lattice rhythm for what is yet to be I became. So it's kind of like some knows to update his structure, but in a real scenario this would be a good force the person I want to do for this one do for obedience publicity. It's like a policy, it's a force field but for security measure people can go into the places that are safe, for like a security of people that feel the world so people can come and you them with guns. So this policy is like anywhere that's literally suffering, like use this force to affect to protect that area and get safe because it's hidden. You don't know, we can't go to that area because you don't know what it is and saying it doesn't matter if it's done or not. You protect the people that are most valuable, most useful, actually needed in society. Without quoting this one's it's secret, hiding secrets in plain sight. This one wants to do it. So this is a this into verification. So this was actually modeled on my first one, which was you have to double the energy to go to one place because if you plug, for example, the Laplace integration matters because how can I put it? So if you're going from point A to point B, there's a point that's point A. There's a point that A won't know that's AB. If I start from A and I go to point B, that's a half of B. But half of B done. But this means I'm at 90 degrees, zero. If I came from 0 degree, if I rotate this, that means I am going from B 90 degrees. I've walked 90 degrees, or half, which is halfway to B from A. And I'm now at 0, 0 from 0 or 90 degrees, or minus 90, depending on the polar axis, nil to 90, minus 90 or minus 80. So this is a polar angle, but this is a amount of energy I need to sustain will be polar. So this will be what we do pi half pi, this will be half pi, pi divided by 2. Not going into pi divided by 4. Pi divided by 4 because it's half, so it will be so pi divided by 4. Let's calculate that. Pi divided by 4. This is pi divided by 4. 0.7. Now this unit 0.785. It's just one person is going there, but 0.4 the pi r squared will be the area. So pi divided by 4 times a radius. The radius is just one whole unit, one whole diameter times 1. Times 1, those would be times 10. Let's use the number 10 because 10 times 1 will give me times 10. 0. So because I divided pi divided by 4, 0.7F85391 times 10 will be 7.85398 times 10. This will be times 10. This will be the unit of pi times 10, which will mean the area of times 10 is half, and this is just half the unit I've gone. So this represents a half, because a half times 10 will give me the ratio of this, because I'm just talking about half, because this is 90 degrees or a half. No, this is a half of 90 degrees, should be 45 degrees. This is 90 degrees, so this will be a half, 45 degrees. The 45 degrees also, so we do times 360. No, times 180, because this is a part between 360 and 180, 180, because I already been 90. So I'll either divide by I cannot convert it to degrees, because let me just use the trigonometry function. So secant I can do the cosine, which is the y, or the secant. Secant is sine over cosine, this will be y over x. I can do the cosecant, which is no, this is no, sorry, the secant is y over x, and no, y x of y, so opposite. No, the cosecant is y over x over y, and the secant is y over x. So this will be the rise over run. But to give me a derivative, I can take a secant, or I can take a cosecant. So if I take a secant of this, I should get a number. But the secant, I don't think. So the secant will give me y over x in change. So let me go to 7.8, but I'm going to multiply this by 180 and convert it to radians. Let's see how I do it. So 180, this will give me secant of 7.8 will give me one. So I've traveled a unit of 100. So we share this unit between what change of y over x. So this is why I matters. This is why I like this calculation. I just take the secant y over x, which is the secant y over x 1.009046692, and that's because pi over 4 is half the duration of x, but this 1 unit is all the whole share, the number 1, and the ratio is 0.094. So now I've taken the out of the unit of 10, because 1 unit, we share this kind of called 10 unit, to join to and from each other. Now this divided by now after divided by times it by 360, divided by 180, but 180 is a polar angle, so I have to find a way, because this number is not an angle, so I have to convert it to an angle. So if I punch this is a number, I can convert to an angle, but how do I give them? I have to convert this to inverse number, so I have to take this number and basically I have to take the number 1 to an angle, and that'll be 2 degrees or to radius degrees. So this is to radian. Oh, this is to radian. So it's in radian mode now. Grade. No, I don't know that fucking degrees. So this is degrees. 100. 100 degrees. But this is in radian. This is radian. Oh fucking hell! I just fucked up. So I'm getting the reverse numbers now. So I should be able to put it back, I hope. So this is 1.9 times radian degrees, 1.0092 degrees, radian degrees. So let me use radian, because let me use degrees, because down quack. 2 degrees. So this is 57.7478, 57.78 7.838329888. So this is in degrees. Now this degree is to be divided by 360. It's divided by 180, and that will give me the ratio of the unit that's actually our invariant. And that's 0.3. We share a ratio of 0.32134055, and that's because it's a calculus. That really is like a literally so divided by 180, and this would be, because it's between A and B, 2 points between A and B. I can do divided by 90, but this is pi r squared. So I'm doing it because pi r squared. No, I haven't r squared it. So then I have to square it first. Sorry, I have to square it because I've done the radius. So that'll be to the power of 2. That'll be 57 degrees to the power of 2. obviously 57 to the power of 2 is what? It's 3,000, yeah, this is number 3,335.272 to the power of 2. This is the angle I'm working on, you know. But you know, the thing I've determined, so I've joined the half, obviously a half. So a half, which is a half times this angle. So basically a half times for 28.91986495, and this is half times the angle in radians because we all share, because you know we all share traveling from A to B, and after now divide if I can get a segment, the area of the energy which is times 360, but you know times 360 is not what I need because I divided by 4, so times 360 will be good because I divided by 4, because I divided by 4 that means divided by 2, this is half pi. Now half pi is 90, so 90 will be 180 times 180, so 90 is times by 1, not divided by 180, and that will give me the full Asian. Now this 180 degrees, basically 180 degrees, basically let me do 180 degrees here because I don't trust myself. 180 180 degrees here. Oh, let me just do 180 degrees here. So basically 180 degrees is 3.14, yep. Which is basically 180 degrees is pi, but so you get 180 times this, so we get this thing times a half times divided by 2, divided by 2. Divided by 2 is 38 point, and then this divided by 2. Oh, sorry, this fucking thing. Times 180 will be. So divided by 2 to the 8.9 times 180, so that'll be times 180, that'll be 5,000, but no, divided by 180, fucking hell. So I divide by 2, and I divide by, and I times by 180, but that's 180, it's the same as times pi. Let me just do times pi, because you know, it's already in radian. So I use radian mode, and I do times pi, and this should give me the 180 degrees. And that's 90. So this is now the 90 point. So this is now proof that I just traveled half, and this half is 90 degrees. 90.852236154. That's again 90.852 double 2 36 91546, and this 467 this is to 1 2 3 4 5 6 7 8 9 10 11 12 decimal places I've got them. 71 because what this will pi, because you know I'm saying to you, it's equivalent because the math works out. I'm saying so this video is very important because the cloaking should work on Laplace integration. So you have to get 2 Laplace integration to have proven to have it. And this I'm saying because one language is halfway, and it shows it's halfway now because you know you just halfway in integration. So you know, so it works. My framework of calculus works like I intended to do. And I'll be using it for this kind of cloaking stuff, you know, because you know I've just been, you know, I hope you guys agree with this thing too, because it's more basically it was basically if you go to my Medium article. So basically, if you go to my Medium article, there should be something there for you guys too, because it's basically this is a poem, "Spirits of the Masquerade." This is like the poem I was talking about, the masquerade. This is how they came about. Because TikTok, you guys can look at this poem. This one I'm talking about the masquerade. Because this is the masquerade. This is like a visual Igbo masquerade that's dancing on Medium call for us as open access. So this you go here, read this poem. TikTok, the hand closed slowly, so you can read it. It says, "My becoming," but you know, this is kind of like being part of my culture, my Igbo, missing all of my friends and being an adult. But this is me now. This is me like sad, depressed. But it's now me dancing outside because I was a masquerade. I was like someone that bought spirit, you know. I was like kind of that person, cherished person. But you know, I'm not that kind of person because it's so gloomy and there's no everything's money. You know, that's the person that's who I am. But you know, that's what I'm saying. So it ties back to the idea of this. But these are a one-dimensional arm. So this the two. We couldn't. So this is a two one. This one is here. This one is here. So this is the trident. This is a consensus tree. And this is the trident. This is basically the if you're running to somewhere, you're already there. You already see if you teleport in a quantum state, you're already there in the quantum sense as well. But I'm saying to you, so basically, this is a Hamilton's representation of it. This one's I'm going to read this article because this one's this one saying how a one-dimensional arm can jump into your reality, can become a three-dimensional arm in your reality because it takes the space of your dimension. You have to calculate itself because it's transcending. So this one's about transcending. How an ant from one dimension can come in your reality and harm you, you know, saying, can buy you. And it's kind of interesting because it's how does a one dimensional ant transform into a three-dimensional using a functional framework? Because the functional framework is the repository that matters to me. So you get the other one on my Devta 2 platform, and that's the last one I need you guys to read. But you know, so we get medium.com /OGIKE. So you get github.com /functor frameworks. And this is what the lambda calculus one the functor frameworks. This repository uses everything as functions. So functions that are heterogeneous only, works the mixed data, works in uniform data. But you know, this is what I'm saying. That's the functor because you know there's a relationship that they share, but you know it depends. All binds are drivers, all squares are not so binders. That's what I'm saying. If you guys follow me, you know I'm very separation concerned person, and this is what matters. This is what the functor frameworks matter. They are not. There's not evidence with disjoint. So if you get the lattice, the coherence, bound, disjoint bound, because they share data and types while they're operating. Doesn't matter how you do it. You know, it's isomorphic relationship, isotropic situation, which means they're isomorphic and they're heterogeneous or homogeneous in the state space, in the sparse states, sparse active. I mean, they know what they're doing. Sparse how they're modeled. You know what I'm saying? And that's how that matters. And this is what the matters. Okay, thank you guys. Now this is just my OG core repository. Again, this is OG-core. Go take a look at a reader of it. That's the OG core teleportation. Basically, this is literally just this is basically a masking. This is a masquerading protocol because it's this is a masquerading protocol. The protocol masks, so it hides you. It makes you fit. It changes your what your medical basically. It hides. It's a force field there's a force field basically. It's a force field that makes you invisible. It's called cloaking. Okay, it's a cloaking device.